Hello everyone and welcome to another AP Computer Science video. In this video we're going to finish up our discussion of inheritance with two main subjects. The first is the overriding of the equals method. And we talked about overriding methods in our last video, how we can change the implementation of a method from the parent if we think we can extend it or change it in some way or add more to it, or we can completely change the implementation depending on what our goal is. And so the equals method is a method that was inherited from object, and by default it's very simple. It only compares references, and that might not be enough for what we consider equality. So for example, we might consider two persons equal, not just if they're in the same memory location. That's a very strict programming definition, but in terms of content, maybe if they have the same name and the same age, then we consider them equal objects or equal persons. They're the same person even if they're in distinct objects in memory. And the second discussion we'll have is polymorphism, the ability to keep specific type objects, inheriting classes or subclasses, in generic variables or superclass variables, and the benefits that we gain from that is particularly in our main method or our main program that we often keep track of lots of different objects. So let's go back to person and let's discuss overriding the equals method. Again, we're given an equals just like we're given a toString by the object class. Even though it's not that great, it's enough for maybe the technical definition. If there are two values in the same location in RAM, then they're equal. But we care more about content, not just the location of RAM. In fact, the location of RAM is often not important at all because we're not in control of that kind of thing anyway. And if it's coincidentally that we're comparing an object to itself, then maybe they would have the same RAM location. But otherwise, it's more about the content. So we're going to override it just like we did with the toString. The requirement is, just like before, we must have the exact same signature. So if the equals for equal signature is public, Boolean, equals. And now here's what's a little bit different. And this is a form of polymorphism. We'll see more about it in a little bit. Is that we don't know what kind of thing is going to be given to us, right? We can technically compare any object to any other object, even if they are of different types. So for example, we could compare a person to a scanner, or a person to a string, or a string to an array list. Now, it doesn't make a lot of sense to do so, but the fact is the equals method of object allows us to do that, and therefore we must handle this gracefully. And so the requirement is the parameter type is not a specific type, but the most generic type possible, or the highest parent we can have, which is capital object. So our parameter is object, and the name doesn't matter. I'll call it obj. The name is not important of that variable. But the point is that we don't know what it actually is. Its object is generic, so it could be anything. So in order to make up an effective equals method, there are 5 facts that should always be true about our equals method. And if we do these 5 things, then our equals can be considered to be a quality equals method. So I'm going to go ahead and put the 5 things. The first one is called the reflexive property. That if you have an object x and you call equals on itself, so you compare an object against itself, always returns true. If your method somehow manages to return true one time when you compare an object against itself with its own method, and then false another time, then that's a huge problem. So that's not consistent at all. So it's like the identity property. I am myself. The x equals x is equal to itself at all times. That's always true. Our second property is the symmetric property. And so to be symmetric means that if you compare two objects, x and y, versus each other in one direction, x equals y and y equals x, because they're the same objects, they should be equal to each other. It should be true both times, right? So the result of x equals y should always be the same as the result of y equals x. So let's go ahead and put that. We're going to put symmetric. So x equals y always equals y equals x. So that may be true, that may be false, but the point is that changing the direction of the comparison should not have an impact on the result. That's what we're saying with our symmetric property. The third property is the transitive property. And we're saying that if we have a situation where x equals y is true and y equals z is true, then the fact should be that x equals z must be true, right? And the same for false. The idea is that the transitive property, just like in math, is saying that if you have two things that are equal and a third thing that's equal to one of those things, then they must all three be equal to one another. And as long as our method can enforce that rule, then our equals is potentially a good equals method. Our fourth property is the consistent property. Oops, let me go ahead. And this one's a little bit more vague, but it basically says if you call the same method on the same objects where no changes have occurred, you should get the same result every time. Equals y called any number of times with no changes to x or y, always give the same result. Right? So if you call x equals y again and again and again, and nothing has happened to x or y to change maybe their instance variables or their values, then the result of the x equals y must always be the same. That's a consistency property. And the last property is the non-null property, or maybe that's not a good name for it, but we'll say null comparison. And essentially what we're saying is that x equals null always returns false. This means that, and this makes sense because if it was not false, that would imply that x is a null value. Null values cannot call methods. Null values are nothing, and you would get a null pointer exception. So the reality is, if x is a non-null object, a comparison against the null value should always be false. So if your equals method can guarantee these 5 things, then you have a good equals method. And it's a matter of just making sure that you compare the proper values for the content. So now that we have our expectations, let's go ahead and try to implement this method. The first thing we should always do, just to speed up the process, is check if they happen to be the same object in memory. That's a real possibility, and that would be very convenient, because then we wouldn't have to check the actual content. If you're in the same RAM location, you are the same object. So let's ask that question. And the way we're going to do this may seem a little odd, but in reality, when you compare with the equal operator to objects, what's being compared is their memory locations or references, not their content. So we can simply say, if this is equal to obj, are they the same object in memory? And if that's true, then we simply return true. This refers to the class or the object we are when the code is running. Obj refers to the object that was given to us. The equal operator compares their references because they're not primitive. So we're not comparing values because they're complex objects, and therefore we're simply checking their references. And if they happen to be in the same location, great, they're the same object. The answer is they are equal. Next, we have to say, well, let's also try to speed this up by saying, you know what, if you're not even in the same category of or thing that I am, then we can't possibly be the same. So for example, if we're comparing a person against a scanner, the answer is obviously we're not equal. We can't even compare the same content because we don't have the same content, right? A scanner doesn't have a name and an age, or a person doesn't have the internals of what a scanner has. And therefore, we should first check, are they different types? If they're different types, the answer must automatically be false. We cannot be equal if we're not even the same type. Now, how do we ask this? This is with a special keyword called instance of. Instance of is a little bit different from most operators because it doesn't take 2 values on the left and right. It takes a value on the left and a type on the right. And the result is true or false, or is the thing on the left of the type on the right. So we'll see this in a moment. So I'll put the question we're going to ask, read different types. And so we're going to write this, and I'm going to write the positive statement first. So I'm going to say if the object, well, sorry, not are we different types. Let's write it better. Right? Is the given object a different type? That's maybe a better way of writing it. So if object instance of, and this is all one word, all lowercase, notice it turned orange, instance of, and the type we are looking for is what we are, in this case, person. And so this is a positive question. This would be asking, is this thing a person? And that's what we want, but to speed it up, we're going to ask the negative question. Are you not a person? Because if you're not a person, the answer is we're not equal. So let's go ahead and put that. Let's wrap this in a set of parentheses. Oops. And then negate it. So now we're asking the question, is the object not a person? And if that's true, then we can't possibly be the same thing, because this class is a person and the thing that was given is not a person, therefore they are simply never going to be equal to each other. And so now, if we're past this point, we have to we're confident that, okay, well, this class is a person and the thing they gave us is a person. Let's make comparisons of their actual content. So the name versus the name, the age versus the age, and so on. But before we can do this, unfortunately, OBJ is of type object, and one of the limits we're going to see in polymorphism, the idea of a generic variable, is that we can't see the content beyond what type is actually the variable. So in this case, we can only see what objects have. Even though OBJ may be a person, in fact, we know it's a person, we cannot access person content if we're looking at it through the lens of the variable of type object. So we need to cast it to a specific type. It's very much like you can't really see the decimals of an integer because integers don't have decimals. But if you cast an int to a double, it's the same value, but now it has a 0.0 or decimal places and so on. And so here we're going to say, take OBJ and make it into a person. It's the same object, but like view it as a person. Use a variable as like a lens or the scope of a person. So let's make a temporary variable, and we'll call it other. And we'll say is equal to, and thankfully casting objects is pretty much like casting primitives. We'll say person in parentheses and the thing we want to convert. So we're saying pass along OBJ into the other variable as a reference, but convert it or view it as a person. So now when we refer to other, we have the same object in memory viewed through two different lenses. So if we use OBJ, we're looking at it as an object. If we use other, looking at the same thing, but as a person. And persons have properties that we can compare, but they are the same object. So let's go ahead and put a note here. We'll say, view the given object as the expected type. And this is why it's important to check this first, because you can imagine if we allowed them to do this and it wasn't a person, that would be like trying to convert a string to a char or a string to a double with just a simple cast. It wouldn't work. It has to actually be able to be cast, otherwise an exception might occur. I believe that exception is a type mismatch exception. But maybe I'm wrong, and maybe there's a different name. But we have to make sure that we are in fact a type before we do the cast, otherwise it'll be a problem. So now for on this point, now we can compare the actual content, and this is an easy thing to do. We'll simply say the answer of we're equal is our names are the same, and names are strings, so we can compare the strings using the equals method of the string class. We can say this.name dot equals, and we don't need to say this dot, but I'm going to. And then we have to get the OBJ's, not OBJ's, but others name. So we can say other.name. And that's one thing. So if their names are true, that's one possible thing that makes them equal. And then we'll say, and your age must be the same. So this.age is equal to other.age, right? So the fact is, every person has a name and an age. And if I can get to the point where I can compare my name to their name, and my age to their age, and they're the same, then we must be the same objects in terms of content, and therefore our answer, this is returned as true. And if either one of them is different or false, then the answer is false. So the and solves that for us. So there is our implementation of equals for our person class. And in fact, for every other class, it's pretty much the same. The only thing that will change is the type that we're checking the instance of, and then the actual comparison of these. So for example, when we do teacher and Gradely, these might be a little bit more complicated. So I'm not going to necessarily do them all, but we'll do student, and then we'll do teacher, and then we'll stop there, because if you can do teacher, it's the same as Gradely. So let's go to student and try that out. So same thing as before, we will override our equals, same exact signature, public boolean equals object, and again, the name doesn't matter so much. But there it is. And again, it even tells me if you want to put the override, you can. And there it is. And now, again, same thing. Let's do this. The exact same premise. We will ask if this is equal to OBJ, return true. And then now if not OBJ instance of, in this case, student. If we're not a student, then we return false. And otherwise, now we are sure that they are a student, so we can say student, and I'll call it other again, is equal to student OBJ. And now we can compare the content of a student. And the content of a student is the GPA and the grade level. But we have to also check the name and age. So we could, and so this is where these things become a little redundant. We could check the name and age by accessing them with the accessors, but the parent already did it, so we could compare the or use the equals method of the parent at this point, and that's what I think we're going to do. We're going to try doing something like if, well, we'll return super dot equals obj, right? So that's the first part. And again, the reason I'm doing this is because this handles, which internally we would be going to person, which would eventually handle the name and the age. Now, it's a little bit redundant because since we asked this the first time, then this would be false for sure, and this would be false for sure. So we would just skip those every time. So we are asking a little bit more work, but that's not a big deal. So it works out in our favor. And so if our name and age are equal, and then we can say, well, our GPA, and again, I'm kind of cheating because GPA is a double, and in reality, we should not compare doubles with the equal comparison. We should do some kind of proper comparison, maybe the difference or to some threshold. But I'm going to do that for now just to make this easier. This GPA is equal to other.GPA. That's not a good idea in general, but I'm going to do it just for our example. And then, of course, our grade level should be the same. Right? So if these two things are equal, and then the two that are hidden by this two from the parent call, the name and the age, that means all four values are equal, and therefore we must be equal student objects. And again, I'm going to repeat, the reality is this is an improper way. And if we really want to do this right, I believe a better approach would be to do something. I think the wrapper class double has a method called compare, and we can compare this.GPA to other.GPA. And again, internally, you can see that this method, I believe, what is wrong with this one? First type, second is an int. Am I missing something? Oh, equal to 0. Yeah, because compare returns if they're equal to each other. So this is maybe a better approach because we look at this method. Let's try see if the doc tells us what it is. We'll do compare. And so compares two specified double values. The sign integer is returned as the same. So it is a smarter approach to comparing them if they're equal. And again, it probably handles gracefully the fact that decimal places might be a little bit off internally. But either way, it's acceptable to do it for now in our new example. So there's our comparison. And now again, the fact is a teacher is very, very similar. So let's override the equals method for a teacher. We'll say public boolean equals object obj. And same thing as before. If we are equal to the object, then we simply return true. If we are not of the same type, we return false. So if obj is not an instance of teacher, then we're clearly not the same object. Otherwise, we cast obj as a teacher. I'll call it other. And then now we can compare the content. Now here it's a little bit different because the content is the department. That's one easy thing. So let's go ahead and we'll make an answer. We'll say boolean. Actually, let's make this easier for ourselves. We'll say if this dot department equals other dot department, and we'll negate this. We'll say if they're not equal, then we return false. So if our departments are different, then we know we're not equal. And then now the reason I did this is because unfortunately we have to go through an entire array list to compare all the content of students, but thankfully because we overrode the equals method of student, this should be relatively easy. And let's do this. We can say for every student ST in our advisory, because you can imagine maybe there's two Mr. Smiths and they both have advisories and they both teach in the math department, but they have different advisories. They're just not the same person. And they may seem like the same person because of their name and because they're both math teachers, but the reality is they would be distinct Mr. Smiths. So we have to compare their advisory content as well. And we'll basically say if we manage to find a student that's not equal to each other in the advisory, then that means that they must be different students. And now this is not perfect because the reality is, well, what about the order? What happens if they just happen to have a different order? But we're going to make assumptions about, well, the order should be the same for the advisory, otherwise you can't be the same advisory. So for every student in this dot advisory, no, we have to use indices, don't we? So let's use a regular for loop. So say for int I equal to 0, I less than this dot advisory dot size, I plus plus. If this dot advisory, if our ith advisor or advisee, and here's where it's nice because we wrote the equals method for each student, and if we're not equal to, the other ith advisee, so other dot advisory dot get I. If they're not equal, then we return false. So as soon as we find a mismatch in our advisees, we clearly are not the same advisor. And then if we manage to get through that and check every advisee, then we have checked that they have the same department. We have checked that they have the same advisory. And now the only thing that's missing is the parent content, which is the name and the age. So we can simply return that. We'll say return super dot equals. Super dot equals obj. Because now this will check the name and the age. So now we'll say, are they Mr. Smith? Are they the same age? And then we're good. So the idea is that equals can be complex depending on what kind of content you have. And I recognize that this is not necessarily a perfect solution because it makes the assumption that the advisory will be in the same order. And maybe you made a copy of Mr. Smith's object and you reordered the advisory. It's technically the same person, same advisory, they're just out of order. And this would say they're not equal. So maybe this is not the best implementation. But I think the takeaway is obvious here, is that we have to decide, are they the same reference? Are they different objects? And then make an attempt at comparing their content. So I realize this was a long video. I'll stop it here and we'll do one more video that will talk about our polymorphism, the ability to hold generic or create generic variables and hold specific types, and the advantages that Java has for us in that situation. Once that's complete, we've talked about all of inheritance, and we only have one more subject to discuss for the course. I'll see you in the next video.